With holistic management, we work to understand nature and partner with it to improve the function of the 4 ecosystems processes. And the key there is that covered soil. By covering the soil, we're better able to manage and improve the water cycle so that there's more water infiltration and retention in the soil. Likewise, with covered soil, the mineral cycle, which is the carbon cycle or the nutrient cycle, is more likely to happen so that the matter above the ground can be incorporated into the soil to feed the microbes. With energy flow, we focus on taking the energy from the sun and turning it through plants and the photosynthetic process into food and energy for animals. The more plants we grow on a given area, the longer we grow them, extend their season, then the greater the energy flow. Lastly, with community dynamics, we're looking at how do we increase biodiversity? How do we work with the relationships such that they are symbiotic, so that we can have a stable and sustained community. The focus with holistic management is to know what tools are available and how those tools affect the environment within which we are managing. Each environment is different and the tools will affect it differently. So holistic management is an adaptive management tool in that we look at the response and look at that feedback loop and respond to it rather than assume we're right. It's also a decision-making tool that focuses on a whole systems approach, looking at the whole system and how it functions and how to, again, to work with the relationships within those systems for a more effective management of natural resources, improving soil, habitat, increasing water infiltration, and carbon sequestration. While results have varied from producer to producer, we've been really amazed at some of the results that people have achieved. And as you'll see in the following slides and the photographs of the different landscapes and how they've changed, it's quite remarkable what these people have been able to accomplish. And some of those results are 300% increase in plant species, a 100% increase in soil carbon, a 400% increase in stocking rate, a 40% decrease in labor, a 50% decrease in bare ground, an 800% increase in soil permeability, a 300% increase in profitability, with some people having as high as 1,400% increase, a 500% increase in riparian bird population, and a 900% increase in rooting depth of plants. These results were achieved because of the management practices that were changed and the hard work of the managers to continue to improve that management. One example here is the Hollister Hills in California in 1999. In the foreground you see a severely grazed landscape, brown and struggling. In 2000 you see the same landscape, much greener. You see the background in the hills are still less green than the foreground, and you have a lot more pasture production due to planting. With planned grazing, you can actually build topsoil. Here we see two different shovelfuls of soil. On the left is a shovelful from land with livestock. You can see the dark layer of organic matter that is a result of dung and urine and plant material being incorporated into the soil and the microbes utilizing it to build more organic matter and sequester more carbon in the soil. On the right-hand side is a plug of soil from land without any livestock. You can see that there is no dark, rich layer of organic matter from that side of the fence. In this picture, taken in Australia, we see how planned grazing can actually fireproof the land. On the left-hand side is land that has been holistically managed. On the right-hand side, the fire came through on that landscape, burning all the grass on the ground. But as it hit the fence line right there in the middle of the picture, it stopped, because on the holistically managed side, the grass was green and it wasn't a fuel load for the fire, so that the fire actually stopped at the fence line because of the management on the left-hand side of the picture. Cockatoo Creek is also from Australia. This is a picture of what it looked like in 1992. By 1999, with planned grazing, this area is now green year-round with lush vegetation because of the planned grazing. This shows the significant difference that holistic planned grazing can create. This is a picture taken at Beaver Creek in Lander, Wyoming. On one side of the bridge was a conventionally grazed landscape with very short grass, little for animals to eat, a highly eroded stream bank, and a shallow stream bed. On the planned grazing side, however, you see a lot more vegetation. The dark green of the grass shows the health as well as the vigor and height. The stream banks are protected. They have plant matter on them, protecting them, stabilizing them. The stream bed is deeper, cooler, and more inviting to invertebrates. In Chapa de Mota in Mexico, there was a land reclamation project using a variety of animals. They were put on this hillside and fed, trying to address some of the erosion that was happening in the landscape. In the bottom right-hand corner, you see some of the erosion that had begun with deep undercuts in the top part of them. You see here that by a year later, the grass and plants have started to grow up the hill, covering the bare soil. Likewise, at the top where there was the undercut that would continue to erode back up the hillside, the animals have knocked that undercut down so that the cutting back into the soil will slow down as the grass plants are then able to stabilize that edge. Sonolita Farm in Namibia in 1983. Very little vegetation, mostly woody species. By 1984, you see that there were grass species that had come up in between, and the woody species are of healthier quality. The Bose Ranch in New Mexico in 1984 had 11% snakeweed, which is a noxious weed with little forage value. By 1991, that snakeweed had been reduced to 1% of the forage stand, with grasses replacing. The Dawley Ranch in California in 1988. Again, the riparian area is limited in vegetation. The gravel bed is pronounced in the center of the stream. By 1992, the riparian area had a variety of vegetation with cottonwoods, willows, vines, and grasses. It had become a riparian jungle. The fish and game biologists there estimated that there were no fewer than 24 species of vertebrates utilizing the gravel bed, and that there were over 160 in the riparian jungle. The creek now flows year-round, and the ability for it to handle or support higher successional species like trout and salmon have a greater potential. In New South Wales, Australia, one of the producers there, after a rainstorm, captured water coming into his land, which had a lot of sediment in it. That's the water to the left. To the right, he went downstream where the water exited his managed land and put the bottle in the stream, and it came out clear. The reason that happened is if you look at these two pictures, which took place in only a 500-acre area, upstream from his land, you can see that there was sediment in the water coming in quite heavily due to the fact that there was too much water for the soil was not covered sufficiently to capture it, so the sediment came off the land and into the stream. But because on his 500 acres every bit of land was covered, then the soil held, there was no additional sediment load into his part of the stream, so the stream itself and the vegetation in it could actually filter out the sediment that had come in, so that by the time the water left his property, it was clear. On Brussels Farm in South Africa, there was a fire that devastated Dick and Judy Richardson's ranch in 2002. But 2 years later, through planned grazing, they had been able to have their land recover with good regrowth and ground cover. However, this was not true for his neighbor. As you can see on the left-hand side of the fence, the ground cover and the growth has just not happened the same way as it has on the Richardson side, because they used planned grazing and a high animal impact to jumpstart the health process, whereas the neighbor didn't, and the plant regeneration was not the same. In Montana, Don Scholes focused on a rangeland restoration project. You can see on the left-hand side of the picture a grass plant that he dug up from his property. You can see the vigor, the height of the plant, the dark green color. On the right-hand side, you see a plant that he has picked up, dug up from another on the other side of the fence where there hasn't been livestock. The plant is much smaller. There's a light color. It's struggling in a way that the other one isn't. These are this exact same species of plant, and they're just dug 30 feet apart on two different sides of the fence. But on the left-hand side is Don's, where he's used planned grazing, and on the right-hand side is an area where there has not been livestock. This is a picture of what Don's rangeland looked like in 1986. He used 600 cow-calf pairs to revitalize the landscape and build a healthier stand of a perennial grass species, which is the western wheatgrass. The Nevada Mine Reclamation Project, you can see what it looked like before treatment. Then in 1990, they had 600 head of cattle on 10 acres of that mine, and they seeded it with a native mix of grasses and forbs and brush and fed the animals on it. 1 year later, after a 6-inch rainfall during the course of that year, they were able to grow 6,800 pounds per acre of dry matter at a treatment cost of $300 per acre compared to the $3,000 or $5,000 that's typical for that reclamation work. And the results were such that they had a solid stand to cover and stabilize that slope of soil after that reclamation. This chart is an example of research done in Clare and South Australia, looking at how planned grazing increases soil water infiltration. In 2001, the baseline, the planned grazing was similar to the regional average, which was 1 millimeter per minute of water infiltration. By 2003, the regional average had remained the same. However, the planned grazing infiltration had risen to 8 millimeters per minute. In 2005, with a greater rainfall, the regional average crept to almost 4 millimeters per minute, but the planned grazing reached 19 millimeters per minute. Montana, this is a picture taken in a serious drought year. On the outside of the fence, you see what's happening with few animals wandering around all year long. On the inside of the fence, this is an enclosure where cattle are loaded. So there were 700 cattle for once a year with a long recovery period. So on the outside of the fence, what we see is a less resilience in the landscape and an ineffective water cycle. And you can see the results of it. Inside the fence, you see greater resilience because there's an effective water cycle and mineral cycle that has allowed those plants to flourish even in a serious drought year. If you look at the Babbitt ranches in Arizona, where they were simulating nature using cattle, this is what an enclosure with 400 cattle bunched for 2 acres for 2 hours looks like after the cattle leave. This is the same area after sufficient recovery period. And you can see the difference again merely by allowing the animal impact to happen and sufficient recovery. Land regeneration with livestock happens because of the animal impact that breaks the hard soil surface and chips it, which allows water to infiltrate. It also helps to bury the seed and compact it so that you have a good seed-to-soil contact. And lastly, it lays down plant matter on the soil as cover and mulch. The grazing that the livestock does turns the old plants into dung and urine as fertilizer. And in pruning the plants, it results in root dieback, which feeds soil life. All of this makes sense to any person who gardens. So with holistic management, we create resilient landscapes. Just as you can see in this picture, the green area is a matter of management. It's not irrigated. It's how they're managing the land that allows that landscape to be green while the surrounding land around it is brown. If you'd like to learn more about how to create resilient landscapes with holistic management, please contact us on our website or at hmi@holisticmanagement.org.